Hello, this is John Hart, and we'll be going over ANOVA in PSPP. And we'll start with Excel. And here are the three groups. We have a group column. All these ones are students in group 1. First student has this score. Second student has this score in group 1. And then group 2. First student has this score in group 2. Second student in this group has this score. So group 2 students and group 3 students. And we'll left click and highlight all the data. Go down far enough, make sure you capture all the data. And that's far enough. And then right click, copy. And we'll head on over to PSPP. It defaults to the variable view in its spreadsheet. We want data view. Left click in the upper left, and then on the keyboard, Control V. And now we'll go to variable view. In the top row is the left-hand column, which was group or factor. 3 groups, 3 factors, and then the other column was scores, and we'll click out of that one. And it looks good there. And we'll go to Analyze, Compare Means, one-way ANOVA, one independent variable, that is by group, 3 groups. And dependent is scores, and factor is group. Statistics, we'll click on the descriptives box to get our means and number of students in each group. Homogeneity tests for equal variance between the 3 groups, a requirement for ANOVA. And then post hoc, there's a theory that the more comparisons that are done, the chance that we'll get a p-value that's randomly statistically significant. So not all statisticians are in agreement with that theory, but we'll play along here. We'll use the top test to make it a little more difficult to get a statistically significant p-value. So instead of 0.05, it adjusts it down to maybe 0.01. Then we'll click Continue, and then click OK. And we'll come down here to our PSPP symbol, and then click on the output. So here's our 3 groups, N, 38 in each. For ANOVA, unless it's paired ANOVA, this is unpaired ANOVA. Does not necessarily have to be equal sample sizes. Here are the means. Looks like group 1 did the best. And our test for equal variances has a formal name, Levine's test. It's checking homogeneity or equal variances, and the sig is the p-value. It's not statistically significant. It's greater than 0.05. That means variances are equal between the 3 groups. ANOVA is telling us that there is a statistically significant difference in means somewhere. In multiple comparison, that's the post hoc, using Bonferroni correction of the alpha. And sig over here, we see one statistically significant p-value. That's the 0.031. That's 2 to 1, group 2 to 1, or 1 to 2, same comparison. And all other comparisons are not statistically significant. And that concludes this presentation. And thank you for watching.